Finding factors of quadratic equation. Quadratic equation involved variable will look like ax squared plus bx plus c is equal to 0. As it is an equation, it will equate to 0. X here is a variable. In place of x, we can have y, z or anything. A, b, c are quotients of variable x. A not equal to 0 means whenever we keep a equal to 0, the first term ax squared will become 0, which makes that to be a linear equation. For a quadratic equation, the highest power of x has to be 2. Quadratic equation means degree of that particular equation is 2. Now, how to factorize this quadratic equation? For that, we have 3 different methods like using algebraic identities, splitting middle term, or using quadratic formula. We'll take some quadratic expressions and try to understand these methods. Let us take an expression x squared plus 12x plus 36. This is a monic quadratic expression. Monic means whenever we have the quotient of highest degree as 1, here nothing is mentioned, which means it's 1. So whenever we have this value as 1, it is called as monic quadratic equation. In this case, we have to check the last term, that is 36 here. If 36 can be written as a square of any number, 36 is 6 square. In that case, we will check the middle term. If middle term can be written as 2 into this number, that is 2 into 6 is 12. The middle term is same. In that case, we can directly use the algebraic identity a plus b whole square is equal to a square plus 2ab plus b square. Here in place of a, we have x, that is x square. So a is equal to x. In place of b square, we have 6 square. So in place of b, it is 6. In the middle term, in place of 2ab means 2 into x into 6, that is 12x. So we are going to use this identity from which we can write this as x plus 6 whole square, means x plus 6 into x plus 6. On factorizing the given expression, we get x plus 6 into x plus 6. Now let us consider another example. In this case also, the last term can be written as a square. It is 7 square. But here we have minus. Even check the middle term, it can be written as 2 into 7, that is 14. Whenever we have minus here, we have to write it as x minus 7 square. So this can be factorized as x minus 7 into x minus 7. Now consider another expression, 9x squared minus 16. Here the middle term is missing. The last term can be written as square, that is 4 square. And the first term can be written as 3x whole square. Now this resembles a square minus b square identity, which is nothing but a plus b into a minus b. Using this identity, the expression can be factorized as 3x plus 4 into 3x minus 4. Coming to the next example, x squared plus 11x plus 24. This is again a monic quadratic expression. And if we look at the last term, this cannot be written as square of any number. In that case, the first step is to identify factors of this number. 24 factors, we will write it down. It can be written as 2 into 12 or 3 into 8, 4 into 6. From these factors, we have to pick one of the pairs in such a way that whenever we add, it has to give this middle term quotient. Here the quotient is 11. So adding these two will not give 11. If we add these two, it gives 11. So we are going to consider this pair. And then we will split the middle term in such a way that x squared, use these two factors 3 and 8 plus 3x plus 8x plus 24. From the first two terms, we can take x as common. So it is x of x plus 3. From the next two terms, take 8 as common. 8 of here x. 24 is 8 into 3, so plus 3. Now this is one term and this is one term. Terms are separated by plus or minus signs. So from the first term and second term, x plus 3 is common. If you take x plus 3 common, the remaining thing here is x. And from the second term, it is 8. So the given expression can be written as x plus 3 into x plus 8. In case if we have negative signs, then also just factorize this. When all signs are positive, we have to add. Now whenever we have a negative sign, it means we have to subtract one factor from the other. First step, we will identify the factors. For 42 can be written as 2 into 21, and then it is 3 into 14. Then we have 6 into 7. If we check 6 and 7, we have to subtract the factors. Subtraction of these two will not give 1. Here minus x means minus 1x. 1 have to get. 3 and 14 will not give 1. 6 and 7, when we subtract them, we'll get 1. So 6 and 7 are the required factors we are looking for. We know that one of these factors has to be negative. Depending upon the sign of the middle term, we will use that particular sign for the highest factors among these two. Among 6 and 7, 7 is higher. So we have to use negative sign for 7. Now split the middle term again, x square minus 7x. Then for 6, we will write plus 6x minus 42. If we check here, minus 7 into 6 is minus 42. So minus 42 is here. So this way of doing is correct. So we'll take x as common. From these two terms, it gives x minus 7. Here 6 as common plus 6 of x minus 7. From again these two terms, we can take x minus 7 as common. And the first term will have x, and from the second term 6. So the given expression can be factorized as x minus 7 into x plus 6. In similar way, consider when we have x square plus 3x minus 54. Here the last term has got negative, but the middle term is positive. In this case, after factorizing, whatever is the highest factor we have identified, for that we will use a positive sign. Say 54 minus 54 can be written as 9 into 6. There are so many other factors, but we are choosing these because when we subtract these two factors, it gives 3 as a value. So here the middle term has got positive sign. So for this higher factor, we will use positive, and for 6, we will use negative. Means this splitting can be done as x square plus 9x minus 6x minus 54. From first two, we'll take x common. From these two, we'll take minus 6 as common. X, here minus we have already taken out, so we'll have plus 9. Now we can take x plus 9 as common. That leaves x minus 6. So this can be factorized as x plus 9 into x minus 6. Now we'll consider a polynomial which is not monic. Means here in place of a we have 9. We will again follow the same steps. Check the last one. This can be written as a square. Then now check the first one also. 9x can be written as 3x whole square. We'll try to see if 2 into 3x into 7. 2 will take here, 3x from here and 7 here. We'll multiply this. 2 into 3 is 6 into 7 is 42x. Is satisfying the condition. These two terms are equal, whatever we got here and the middle term. By splitting this Here we have positive sign and in middle we have negative sign. So this can be written as 3x. We consider the sign of middle term minus 7 whole square. This is again from the identity a minus b whole square is equal to a square minus 2ab plus b square. But in case we have an expression wherein the first term and last term cannot be written as squares, in that particular case, multiply this 3 with 15. So 3 into 15. Ideally, when it is like ax square plus bx plus c, we are going to do a into c. Multiply the quotient of x square with this constant value. This gives 45. Now factorize 45 so that we have to get 14 on adding those factors. As we have less sign here for the constant term, we have to consider adding the factors. When the constant term has got negative sign, in that case, we'll go for subtraction of the factors. Now, it is plus, so we have to add the factors. On identifying the factors for this, it is like 3 and 15. So, when we do 3 and 15, adding it will not give 14. So, the next thing is we'll go for 9 and 5. So 9 plus 5 is 14. We'll consider these two factors. So this can be written as 3x square. Now the middle term can be split as minus 9x minus 5x. Here we have negative sign. So for both the factors, we'll take negative sign plus 15. From these two, take 3x as common. Here we'll have x minus 3. From these two, take minus 5 as common. In minus 5x, we'll have x. This is plus. Plus is nothing but minus into minus makes plus. 1 minus has gone out, so the remaining minus will have here minus. 15 is 5 into 3, so we'll have 3. When we take x minus 3 as common, this leaves 3x minus 5. Consider this particular expression x square plus 3x plus 1. In this, we cannot use any of the identities like a plus b whole square or a minus b whole square or a plus b into a minus b. Those identities we cannot use. And even when we check here, this is a monic one and here 1 is there. So 1 cannot be factorized in any way, in any rational way such that it gives 3. So 1 means we can write it as 3 into 1 by 3. But on adding or subtracting these values, we cannot get the middle term 3. In such a situation, we have to use a different formula. Now, when we consider a quadratic equation to be in the form of ax square plus bx plus c, in that particular case, x can be found using a formula that is minus b plus or minus root b square minus 4ac by 2a. Here plus or minus because for quadratic equation we have two roots is two x values that satisfies the equation. One will have a plus sign and the second will have the minus sign. Say the x1 is the first value. In that case we'll take minus b plus root b square minus 4ac by 2a. And for second value of x, we'll consider minus b minus root b square minus 4ac by 2a. Let x equal to, this is like in place of a we have 1, in place of b 3 and in place of c again it's 1. Minus b means minus 3 plus or minus root b square that is 3 square minus 4 into a means 1 again c means 1 upon 2a, 2 into in place of a 1. This gives minus 3 plus or minus 3 square is 9, 4 into 1 is 4 upon 2 into 1 is 2. That is nothing but minus 3 plus or minus 9 minus 4 is 5 upon 2. So we have two different values for x here. That is, first one would be minus 3 plus 5 upon 2. And the second value is, the first value and the second value is minus 3 minus root 5 upon 2. To write it as factors, what we have to do, when x is equal to 2, the factor would be x minus 2. In similar way, here x minus of minus 3 less root 5 upon 2. This is one factor, and coming to the second factor, x minus of minus 3 minus 5 upon 2. Second factor. You can take minus in, that gives us minus 5 upon 3 into x plus 3 plus root 5 upon 2 as the factors. In this way, we can factorize the quadratic expressions. In this video, we have seen how to factorize a quadratic equation in one variable. It resembles ax squared plus bx plus c, where a is not equal to 0. For that, we can use three different ways. One is like using algebraic identities, or by using splitting middle term, or by using the quadratic formula. The quadratic formula is minus b plus or minus root b squared minus 4ac by 2a. While doing this, root b squared minus 4ac, at times we will get negative value under root. When we get such things, it gives a complex root. That is an advanced level, which we will look in a different video.